Now we've got the right idea. So if you installed this pump on Lake Superior, how long would it take? Things are getting hotter and hotter here on Earth. It's getting out of control. So let's try something new. We're going to take all of Earth's water and pour it on the sun. I'm talking every single drop. Maybe that'll cool things down a bit. A big ball of burning hydrogen, 1.3 million times the size of Earth. It's so hot that it's like 15 billion atom bombs exploding every second. It's got a temperature of 5,600 Celsius, 10,000 Fahrenheit. Okay, it's not actually a big ball of burning hydrogen. About 70% of the sun is hydrogen, and then 28% is helium. The other 2% is comprised of carbon, nitrogen, oxygen, and other elements. The sun is super far away. It's about 400 times further away than the moon. That's 150 million kilometers, 93 million miles away. For reference, the circumference of the Earth is just 40,000 kilometers. So talk about being a long road trip. Or space trip. And it's no ordinary fire that burns inside the sun. The huge amounts of heat and light that are given off come from nuclear fusion reactions. We'll come back to that later. But this is the fire that we're tasked to put out. It's not just that the sun is hot. It's like a ticking time bomb. The sun is getting hotter and hotter every second. So maybe you're wondering, is that what's causing global warming? Well, no, that's still being caused by us humans and the carbon dioxide we release into the atmosphere. Sure, the sun is getting hotter, but only about 1 degree every 100 million years. Okay, let's be real. Things are getting a lot steamier on our blue marble. So, maybe instead of getting rid of fossil fuels, we can just turn the sun's thermostat down. And this is how you're going to do it. By taking all the water on Earth and pouring it on top of the sun, kind of like the Ice Bucket Challenge, but more of a cosmic scale. Maybe that'll make the sun a little cooler. And if that doesn't work out, we've got one more trick up our sleeve. I'll tell you about that later. The first thing we need to figure out is how much water there is on Earth. Well, 71% of the planet's surface is covered in water, which is 1.3 billion cubic kilometers, 332 million cubic miles, worth. That's 554 trillion Olympic-sized swimming pools. It's safe to say that's a lot of water. Okay, so now you've got a handle on the awesome power of the sun and the enormous water resources of Earth, it's time to get started. Why don't we test our theory with something a little bit smaller? Instead of all of Earth's water, and less resource-intensive. Before we take off, the first thing we need to figure out is our spacecraft. For this mission, we're going to be using the Parker Solar Probe. This ship is about the size of a horse and weighs 555 kilograms, 1,224 pounds. I'm sure adding a small glass of water to the ship won't hurt. In 2018, the Parker Solar Probe traveled the closest a ship has ever been near the sun. And for this mission, we're getting real up close and personal. Well, sort of. At its closest, this ship will still be 6.2 million kilometers, 3.9 million miles, from the sun. Wait a minute, NASA, can't you get any closer? No, NASA says it's super hard getting to the sun. And it takes 55 times more energy to get to the sun than Mars. I'll tell you why in a second. As the probe takes off, the weirdest thing will happen. It'll shoot backward instead of forward. This is because the Earth is traveling very fast around the sun at 107,000 kilometers per hour, 67,000 miles per hour. To shoot something to the sun, you need to account for the Earth's momentum. So instead of launching forward, it launches backward, and it ends up going sideways until it reaches our star. Simplest way to think about it is kind of like when you take the wind into account when you're throwing a frisbee. Not that I'm any good at that. Okay, since the probe will take a while to get to the sun, let's fast forward a few years to where the probe is now in place. As close as it can get to the sun, and a robotic arm comes out, turns the water upside down. Right on top of the sun. Well, in milliseconds, with a brief hissing sound, the water just turns into vapor. Absolutely no change to the sun. Well, actually, if we get a measurement from the Parker probe, it seems the sun is a microscopic bit heavier. Heavier? I thought the sun was going to get doused and get lighter. Okay, well, maybe the probe got the measurements wrong. Okay, time for your second attempt. Only this time you're going to get serious. No messing around with a wee glass of water. Admit it, that got us absolutely nowhere. This time, we're taking an entire lake from Earth and dumping it on the sun. Let's take Lake Superior. This lake is massive in terms of surface area. It's the largest lake in the world. In terms of volume of water, it's the third largest. If you took all the water from Lake Superior and poured it over North and South America, we'd all be standing in 30 centimeters, 1 foot, of water. So how are we going to drain this lake? Well, first we've got to assume that we've got permission from the federal governments of Canada and the United States. After that's done, we execute. We dig a drainage channel and connect it to a pipeline that'll take it all the way to our starships located at SpaceX headquarters in Texas. Yeah, you're going to need a bunch of those to launch all this water at the sun. But how long does it take to construct a pipeline? Well, it could take anywhere from 5 to 10 years. Well, we don't have time for that. Maybe we can borrow an existing oil and gas pipeline. A pipeline that carries 3 million barrels of oil a day. We could repurpose it to carry the water. Well, let's see, that would still take about 70,000 years to transport all the water. That's a problem. Okay, the pipeline method is way too slow. We need a better idea. What if you used a really powerful pump instead? The most powerful pump on Earth, which you'll import from the Netherlands. The Nijhuis pump. It can pump 1,200 cubic meters, 42,400 cubic feet, a second. At that rate, it would pump 1 cubic kilometer in about 10 days. Then you'll pump the water into huge tanker trucks. The biggest are the large-scale construction tankers. Those trucks carry 227,000 liters, 60,000 gallons, to get all the water out? Well, Lake Superior.